So in our research group, we want to build micro machines and micro robots that can swim in solution. And that is difficult because at small length scales there are no motors or parts that we can just buy. Therefore, whatever we build has to be really simple. And the simplest possible scheme that we can think of is just simply something that expands and contracts, or maybe something that flaps, opens and closes, like in a clam. But the difficulty is that if one builds something that's really small, then this kind of flapping motion doesn't work, because at small length scales, swimming is really different from the kind of swimming that we're used to. And the physics tells us that simple opening and closing doesn't work. And this is known, and it's been known for more than 30 years as the scallop theorem. It's due to Purcell. And the scallop theorem teaches us that these kind of flapping motions do not apply in water. But the interesting thing is that not all liquids are like water, and that is really where our research comes in.
Here, this is a beaker of hyaluronic acid. This is a shear thinning fluid. And when I move the spoon slowly in the fluid, it will be higher resistance. But if I move really fast the spoon in the beaker, it will be lower resistance, so low viscosity at higher speed. Here is the micro swimmer that we built in the shape of a scallop. The width of the scallop is 300 micron. We made this by 3D printing and then micromolding technique. We can control the opening and closing of the scallop by using an external magnetic field. And we can also control the speed of opening and closing of the two shells.
Because of the scallop theorem, this micro robot does not move in water. However, there are fluids other than water that have different properties, so-called non-Newtonian fluids. And they include most fluids one finds in the human body and tissues, such as blood, the vitreous in the eye,